And I forgot to record. Okay. Whoops. If it is still an indeterminate form, you can apply L'Hopital's rule again. Does that answer your question? Okay. But it has to be indeterminate. This only works if you try to evaluate your limit and it's 0 over 0 or plus or minus infinity over infinity. It's the only time we can use this. Now, there are actually other types of indeterminate forms. Okay.
Pi over pi. That's one.
That would be one. Good try, Zach. I appreciate the effort. So 0 over 0, 1 to the infinity, infinity minus infinity, 0 times infinity, and infinity to the 0. Those are all indeterminate forms. Okay? And we can actually use L'Hopital's rule if we rewrite it to be a fraction, 0 over 0, infinity over infinity. Now that is something that you're more going to focus on in Calculus 2 next year, for some of you, I suppose. How many of you are going to take a Calculus 2 class?
I didn't even know there was Calculus 2. There's BC.
Yeah, so you...
BC is 2?
Yeah.
Nice.
What comes after Calculus 2?
What?
What comes after Calculus 2?
Calculus 3.
Like, but then does it keep going? Or like, what's the
There's 3
highest?
semesters.
What's
of
the highest?
calculus. Well, then you get into like theory classes, like number theory and abstract algebra, and
What was the highest math class?
well, it was called applied calculus, but it was like basically proving all of this stuff.
Awesome.
Once you get past calculus, differential equations, and linear algebra, besides the statistics classes, if you're a math major, it's all theory-based. Yes. Oh, you still had your hand up. All right, so. What? I do not know the answer. Okay, so we are going to go ahead and focus on the 0 over 0 and infinity over infinity. Okay? Example 1, please write it down. Okay, so when we do direct substitution, what do we get in the numerator? Denominator. Okay, well that's an indeterminate form. Can we apply L'Hopital's rule?
Yeah. If you get 1 over 0, you get 1 minus 1. E to the 0.
E to the 0 is 1. Minus 1 is 0.
Yeah. Question.
Yeah.
Yes.
What if you have something like 1 over 0 or 0 over 1?
Then that is not indeterminate. 0 over 1, your limit would be 0. 1 over 0 would be undefined. Does not exist.
Just like that one.
Just like Negroes, is that what you're trying to say? Okay. All right, so now we can apply L'Hopital's rule. So we can say that this is the limit as x approaches 0 of what's the derivative of the numerator? Good job. So remember, e to the x, our derivative is the same thing, but then we have to apply the chain rule with the 3. Over what's the derivative of x?
Can you just leave it as 3 to 3? Yeah, aren't you done? Don't we still have to do the answer?
Okay. We're not taking the derivative of the fraction. We're taking the derivative of the numerator over the derivative of the denominator. This is not the quotient rule.
Completely separate.
But what if it was?
Yes.
What if it was e to the 3x squared?
What?
I mean, you can't tell me.
E to the 3x squared?
Yeah.
So it'd be 6x e to the 3x.
So they're just saying
With
that.
square. Sorry. What?
So it's like your potato gets in. Like, why do you just multiply by 3? Is it just like you copy it?
Okay. Derivative of e to the x is e to the x. Inside e to the x is 3x, so change that.
How do you gotta find those?
There's more letters. Yeah, no why.
This was, math was his life, that was his career, so don't say he had no life. People study mathematics. Okay? It deals with the slopes of the tangent lines and what they approach. I can show you a visual here after a while.
Alright.
Okay? So I think I have one, I'll have to find it. Okay, so now we have the limit as x approaches 0 of 3 e to the 3x. Now when we plug in 0, what do we get?
3. Wow.
Done.
That's probably gonna be super hard.
What does this 3 actually mean? Like,
As we approach 0, our y value approaches 3.
This thing looks great.
Well, you guys are complaining, it's just, I put up trig functions and it's like, and whining.
Trig functions aren't our friends.
Functions, all functions are your friends.
No math is our friend.
Okay, so what's the secant of pi over 2? Undefined, there's an asymptote there, so
Where, how do you know
Hey. I broke it.
I'm trying to recalibrate, but
oh, hey!
It fixed it. It's done. It's better. Okay, it's better.
It's green. Everything's good.
I'm gonna give it 5 seconds. I just got a new USB port. That is a brand new USB port that just.
You already broke it.
I know.
we can't learn today.
I know.
So many things against it.
See?
there's somebody going to fix that.
Functions aren't our friends.
And that's what it is.
We're gonna do this one. We're gonna do this one. I want to do this one. Okay.
It's been a little more fun, but
We don't have time. Time is winding down. Okay. I want to do this one.
Time is money.
Okay. What's the natural log of infinity?
probably infinity.
Well, let's think about the graph. What does the graph look like? Looks like that. Towards infinity, the natural log approaches infinity. What about 2 square root of x? You're going to guess? Don't guess. You know what 2 square root of is. Right? You said guess.
No, I didn't mean it.
Well, then.
It was an educated guess.
Okay. So infinity over infinity, this is indeterminate.
Yes, it is.
Okay, so we can apply L'Hopital's rule. Derivative of the numerator.
1 over the n of x. No. 1 over x.
Over derivative of the denominator. 2 times.
Square root of x. Square root of x, right?
The half and the 2 cancel out.
1 over the square root of x.
Yes, okay, yes. I'm just spelling it out.
And also, you could also put the numerator as x to the negative first.
Yes.
Get rid of x over x.
2 and 1/2 canceled. I'm going to write this as 1 over x to the 1/2. All right?
No, put that on one.
You copy that, flip it, and get.
You do, right? Copy that.
You would.
Got it all.
It's a square root of X, right?
Is this why you wanted to do that one,
They
so they
still
can
be-
copy that flip?
That would never get over.
What is this reduced to?
Square root of X over X is root of X over X.
So 1 over square root of x. Now, can we evaluate this limit?
Oh,
Therefore,
Getting very, very small.
That'd be like pretty
I made mine into a donut.
okay. New one. You're trying to keep calm?
Yeah.
Okay.
No. You're smarter than I am.
John, you're smart.
Yeah.
Will we ever get ones that, like, will they ever give us problems that won't be, like, 0 over 0 or negative?
Like 0 times 1/3.
yeah, you just want to show you.
Oh,
Be
yeah.
patient. Okay, so when I tried to evaluate this one, the limit as x approaches negative infinity of x squared.
Zero.
Infinity.
Okay? How about e to the negative x?
1 over it.
Negative.
We assume it's
What does e to the negative x look like? If only I had my other shirt on.
They do like.
DK.
No.
Yeah. If only I wore that shirt tonight. Might fit in that.
Don't worry about it.
What?
I said it was more.
Okay. So L'Hopital's rule, we can use it. Derivative of the numerator.
We can do that one. That one's 2x.
Derivative of the denominator.
Negative weighted X.
Okay.
Could you put, for the original thing, could you put e to the negative x on top and just have it be x squared times e to the x?
Okay.
Because no matter what x is, it still works with.
But this would be infinity times 0. And that is also an indeterminate form. Okay?
Dude, that's what.
Hey, it's on my computer, not up here.
You're about to break it up there.
Okay,
It's all work for you.
now let's evaluate this.
It's negative infinity over You take the second derivative.
But that's also a
No, it's not.
because
That's 2 over.
on the indeterminate form, it's like positive or negative.
Okay, yeah, it doesn't matter if it's positive or negative, okay? We have infinity over infinity. So what can we do now? Do L'Hopital's rule again. The limit as x approaches negative infinity. Derivative of the
Two.
numerator. 2 over
You negative X.
e to the negative x.
Good job, John.
Let's go.
It's 0.
Just like at the beginning.
2 over infinity, therefore
0.
0.
That's a boundary 0 because it's a negative 0. It's a negative 0. It's a
magic. Why did you say it was like infinity over two?
Make an infinite number.
Oh,
It's
Sure.
Your turn. Tell me what this is. Well, not out loud, please.
It's a woman.
Oh.
We don't want to use the hospital rule. I don't want to use the hospital
Rainmaker!
Interviews are Sunday, not Wednesday. It's home and Chelsea.
Oh, of course it's not.
What is it?
Sounds good to me.
What does it smell like?
Mint?
Looks really
That's really
spicy.
strong.
Who are the skills for?
Okay,
Costco.
no.
Thought you
Aaron,
were worried.
what is this?
It doesn't exist.
What?
Because it's 1 over infinity, or, well, sorry, 1 over 0, which 0 means undefined, which means it doesn't exist, Ms. Holman.
Okay, this is not an indeterminate form because it is 1 over 0. Okay? What is happening at x equals 6? There's a vertical asymptote. Okay? Now we could see if on either side of the asymptote, are we approaching the same infinity? Okay? So are we approaching infinity from the left and the right, or are we going in opposite directions? So to the left of 6, which way? Positive or negative infinity? To the left of 6.
Negative. Negative.
Positive, but if you plug in.
To the left of 6 would be
Oh, yeah.
Okay? What about to the right? So they're going in. Because if we plug in, well, when you plug in numbers really, really close, like think about like 6.1. If you plug in like 6.1, where is it going?
Positive.
Okay. And to the left, what do we say?
Are you just plugging into the denominator, or are you?
Both.
Why is it negative on the left?
If you plug in numbers really close to 6, like 5.9, you'd have positive over negative. Okay, so they're going in opposite directions. Okay, so it doesn't exist. Okay?
Wait.
Say anything?
What if you plug in 4? What does that mean?
I know, but it only matters because it's, yes, like what's happening?
that 1 and then 1, 6.
So yes, when you plug in 4, you're like up here, right? But as you get closer, we're approaching negative infinity, which is why we have to look at values. Okay, good review for next week. I mean, the week after. Okay.
It's a good one.
It's a good one? Why is it a good one?
Because putting it back for tricky.
Okay, so if we try to evaluate this, what do we get?
One times infinity.
0 times infinity. Remember? Either. Okay, so this is an indeterminate form. This is the only other one that I'm gonna even have us look at besides the 0 over 0, infinity over infinity, okay? So, Nathan, what did you suggest?
We have to make it into a fraction.
Okay, we can only use L'Hopital's rule if it is in fraction form. So, we can rewrite this as the square root of x over e to the x. Because when we move it downstairs, the exponent becomes positive. And so now it's infinity over infinity.
And find it again.
And so now we can apply L'Hopital's rule. So what is the derivative of the
1/2 x to the negative 1/2.
over?
Yeah.
So you're going to want to rewrite this. Everything is in the denominator, right?
So we're gonna have 1 over.
1 over, all of those are going to infinity, so
How come either the negative x to infinity is 0? That's a big deal.
So e to the negative x looks like this. So before we were looking at negative infinity. So as we go to negative infinity, it goes to positive infinity. As we go to positive infinity, it goes to 0 because there's an asymptote.
Okay, so then if you just have e to the x, then it's the other way, and it goes towards infinity.
Which is a very ton of zeros.
For our answers?
Yeah.
Yeah.
So if you don't know,
That's what I was thinking too.
We looked at on the test.
yes.
Right, but
Oh, this one's 0.
This is the last problem.
I like this taking notes, it's just one subject and then example.
Yes. Did you go into college wanting to major in math?
Yes.
You did.
Yes.
Wow.
I also have my minor.
Ooh. And what?
Wow.
Did you play an instrument or sing?
Yes.
Play us a song.
What'd you play?
What's
What'd you play? Come on.
Who's that?
I'll tell you in a moment.
Good Jimbo.
Okay.
He's a great singer.
Well, when we try to evaluate this, what do we get?
Times 0.
Infinity times 0. So that is an indeterminate form.
Yeah.
Okay? But we can't apply L'Hopital's rule until this is a fraction. How do I write this as a fraction?
Sign of one.
Nice. The sine of 1 over x divided by x to the negative first. And now it's a fraction. Sweet.
I'll have to sign on the bottom.
Because that doesn't sound fun.
You could. Yes, you would have to change it to cosecant. This works out a lot nicer because of what's inside of sine. We have 1 over x inside. Okay, so L'Hopital's rule, because now we have 0 over 0. Okay, so now we can apply L'Hopital's rule. What's the derivative of sine 1 over x? Cosine of 1 over x?
Negative 4 over x squared.
Times 1 over x squared.
Times negative 1.
Negative 1 over x squared.
That's right.
Cry. No.
What is
Jeez.
what's 1 over x? It should be negative x.
That's just
Negative
One squared. Negative 1 x squared.
1 over x squared.
Negative x squared.
Oh my gosh.
Negative x is negative.
I,
0.
you know what I was doing?
Like, what?
I'm doing antiderivatives in my other class, and that's what
And
I'm
I was
taking
going,
now.
Enter bros!
I'm sorry, I will not cry.
You were about to start crying.
I was. What's the derivative downstairs? I'm so disappointed in myself. What happened?
Now we just get 0.
So we have cosine of 1 over x. And when we plug in infinity, it becomes the cosine of 0, which is 1.
Yes.
It's a difference.
So this becomes the cosine of 0.
I want to have it. I want to x approach 0.
Hey, then there's 3 up here too, so it could be that.
Well, then that would change the whole thing. Okay, there it is.
Oh,
No, I was thinking backwards. I really apologize, guys.
wait, that was
Like literally backwards?
wait, so what was
the answer that you wanted?
What's the derivative of the natural log? 1 over x.
Oh,
So
you
I
went
was,
backwards?
yep.
It's alright.
Oh, that's
that's over.
So if I would have said natural law.
No, I would not.
Only one way to find out.
You should.
Turn it